So basically there are three formulae: formula number one, formula number two, and formula number three. First formula, x approaching 0, a raised to x minus 1 upon x is equal to log a. Obviously the base of this particular log is e. Limit x approaching 0, log 1 plus x the whole upon x is equal to 1. Limit x approaching 0, 1 plus x raised to 1 upon x is equal to e. Okay, so these are the three formulae. So this particular part, exponential and logarithmic limits, will be taken in two sessions. In the first part, that is today's session, we'll be just completing this particular thing. Okay, and I'll inform you later when to do this. Okay, because the problems in the based on the first formula are more. So let's do that first. Okay, and if we
So,
finish it very quickly, then only we'll proceed with the second and third. Otherwise, we'll take some other session for it.
could you, what is the third formula? 1 plus x raised to 1 upon
1
x is
upon x,
equal to e.
e, yeah.
Okay, thank you.
Okay, so we'll start with the problems which are based on the first formula. A is a constant in the first formula. Okay, so limit x approaching towards 0, 3 raised to x upon x equal to, this is just to make you comfortable with the topic. Can someone tell me?
So you multiply divide by x, so you get.
X is already there.
Oh, sorry.
Log 3.
Log 3. Sorry, my bad.
This will be log 3. Okay, so x up, x down. The same value should be down. Limit x approaching towards 0, 7 raised to x minus 1 upon 3x. Let's make it 7 raised to 2x. Okay, now the value over here is 2x. So down also it should be 2x.
So remove 1 by 3 and multiply and divide by 2.
So first we are going to remove this 3. Okay. Limit x approaching towards 0, 7 raised to 2x minus 1 upon x into 1 upon 3. Now in this step or next step, you can do this.
So the
Since
one
we require 2x, we'll multiply and divide by 2. We'll multiply and divide by 2. Now, this particular part. What is the answer for this particular part?
so
Log,
log
log 7.
Log 7 into 2 by 3. So the answer is 2 by 3 log 7. You just cannot multiply this.
Will we have to write proof here? Like since x tends to 0, 2x tends to 0.
Correct. Since x approaches 0, we applied the formula for 2x. 2x also approaches 0, tends to 0. I will take some worksheet problems. Just a second. It's in exercise number 9. Yeah. Exercise number 9. Question number 1. Limit x approaching towards 0, e raised to 4x minus 1 upon x. Now here there is 4x, so down also it should be 4x.
So multiply and divide by 4.
Multiply and divide by 4. This will become log e. And log e is 1. Log e is equal to 1. So this is equal to 4.
No, but doesn't this part come in the other part, like comes in the exponential part of it?
No, the formula is same. Now the format is this.
That's okay.
4x also approaches 0. Since and therefore. Second problem, I leave it up to you. Second sub question. It's very simple. Third, if I'm going too fast, please let me know. Limit x approaching 0, e raised to x minus 1 upon e raised to x minus 1 upon x. So that is the question. Just a second. You can try till then. I'll group this e raised to x and minus 1 because we get our format. And this x I'm separating upon x. Split. Split. This part, apply the formula, it becomes log e. This is x upon x, which is 1. So limit of a function minus some other function. You can give limits to both. So 1 minus 1 is equal to 0. Okay. Question number 2, sub question 1. Question number 2, sub question 1. Limit x approaching 0, x e raised to x minus 1, 1 minus cos 2x. Limit x approaching 0, x e raised to x minus 1. Apply the formula over here.
2 sine squared x.
2 sine square x. Limit x approaching 0, x e raised to x minus 1, 2 sine x the whole square. Now there is x over here. So up and down, we will divide and multiply with x. So this was division by x. We'll multiply with x as well. Okay, so we divided, we multiplied. Don't cancel out this and this, huh? That's wrong. Down. 2. Divide with x. Okay.
So divide with x the whole square, right?
This is square over here.
Yes.
So
So by
this is x square. Wait. This is x square. We are dividing with x. This is x. So we are dividing with x.
so you don't need
So
to
we'll
do that,
multiply
no?
with we will multiply with x square because this is not x technically. Within the bracket it is x, but overall it is x square. So to nullify this x, which is x square, we'll
So
multiply with x square.
So I have a
Okay.
doubt. So why
Ask.
can't you? So why the x that you're multiplying for e raised to x minus 1 by x? So you can make it x square with the x outside, and you can use that also, right? X upon sine x the whole square.
Yeah. In that case, this particular x,
You won't have
this
to
particular x
multiply with x square.
and this x, one of the x will get cancelled. Okay. Now see, this and this is gone. Okay. And one more x and one more x is also gone. So technically, this x square and this x square is getting cancelled. Okay. So this is log e 2 into 1 square. This is 1, but then there is square 1 upon 2. I hope everybody understood this problem. Next question. Question number 2, sub question 2. Should I go ahead?
Yes, sir.
Limit x approaching towards 0. 1 minus cos x. X approaching towards 0. 2 sine square x by 2. X will become x by 2 due to half angle.
Can't pay you shit. You should go get a job frying chicken at Popeyes. I just need $400 a month.
I think somebody has kept mic open, please. Two sine x by 2 sine x by 2. So some students might find that square thing which I did in the previous part difficult. So I'm just writing sine 2 times. Limit x approaching 0. X into 2 raised to x minus 1. Okay. Now this particular term requires x beneath it. So multiply and divide with x. Okay. There is x over here. So down also we require x. Multiply and divide with x. Down in the denominator. 2 sine x by 2 into x by 2. Sine x by 2 divided by x by 2 multiply by x by 2. So this is x by 2 over here. So down x by 2 beneath the sine term. To nullify that, we have to write one more x by 2 over here to nullify it. Now these green circles. These green circles are what? They are 1.
So the top one will be log 2, right? Not 1.
Which one?
2 up 2 raised to x minus 1 upon x.
It will be log 2, correct?
Okay.
Ha, by mistake I said 1, sorry. Correct. So log 2 2 into 1 into half into 1 into half. 2 into 1 into half into 1 into half. So this is gone. Denominator will become numerator. X approaches 0. Therefore, x by 2. We applied the formula for x by 2 also. It approaches 0. Next problem. I'm erasing this. Third one. Limit x approaching 0. Now this kind of problem we just did some time back. So group e raised to x with -1. Split this. Apply the formula. So this is 0 because log e is also 0. Fourth one. Now this is a no-brainer. Put the value of x as 0. So this is 1. Fourth one does not relate to any formula. It's just a brain teaser. Question number 3, sub question 1. X approaching towards 0. E raised to ax minus e raised to bx upon x. Now we don't have the format. The format is a raised to x minus 1. So minus 1 is not there only in this. So I'll subtract 1 and I will add 1. To get -1, I'm subtracting -1, I'm adding -1, plus 1. Subtracting 1 and adding 1. Now this got -1. This also should get a -1. So for that reason, we'll put brackets. Okay. We took minus sign common over here. So naturally this got a minus sign within the bracket. Now in the next step, I am going to split limit x approaching 0, e raised to ax minus 1 upon x, e raised to bx minus 1 upon x. Divide and multiply with a because this is ax, so down also we require ax. Here it is b, so down also we require b. X is already there. Don't write ax over here. Huh? This is absolutely wrong. We divided and multiplied with only a. So sometimes we divide and multiply with the x term also. In that case, down in the denominator, x is not there. But then fortunately in this problem, x is there. What is the answer of this boxes? Compare with the first formula. Come on, tell me.
So is it A minus B?
No, this box, Ania.
Oh, so 1. A log E, which is 1.
Log E, correct. And this is also log E into B. And log E is 1. So answer is
A
A
minus
minus
B.
B. A approaches 0. Therefore, AX and BX, they also approach 0. Next problem. Question number 3, sub question 2. Limit x approaching pi by 2. E raised to sin x minus 1 upon sin x. Now this time x is not approaching 0. At the same time, no manipulation can be done over here. No simplification can be done over here. And sin 90, pi by 2 is 90. Sin 90 is what? Sin 90 is what? 0. So we have no other option but then to change the limits. Let x is equal to pi by 2 plus h. As x approaches pi by 2, h will approach 0. So this is equal to limit h approaches 0, e raised to sin pi by 2 plus h minus 1 upon sin pi by 2 plus h. Sin pi by 2
So
plus h.
isn't sine 91?
Yeah.
Yeah. I'm sorry, I just lost track. Correct. So this problem technically these things are not required. Okay, sin 0 is 0, sin 90 is 1. Correct. But then since we have done this, we'll just revise. Okay, you can directly put the value of x as pi by 2. I'm really sorry. But then I'll just teach you this method. Every time it won't be applicable. Fine. Pi by 2 is over here. Plus so in this quadrant, sin pi by 2 plus h will be anyone? Will be what? Sin pi by 2 plus h will be what?
Cos h.
Cos H.
Okay. I think this method will not be applicable. I'll tell you why. 1 second. This is equal to log e as per the formula. But then if h approaches 0, cos h will it approach 0? Will it approach 0? The answer is no. Because we applied the formula for cos h. The moment h approaches 0 or very near to 0, approximately equal to 0, cos 0 will approach 1. So yes. So that was a lose of concentration from my mind. Sorry. So yes, it was very simple and I did not realize it. E raised to sin x minus 1 upon sin x. Yes, sin 90. Sin 90 is 1. directly put the value of x as pi by 2 because okay. So this is e minus 1. Guys, you understood this correction which I've done?
Yes, sir.
Yes, sir.
Third problem. So that H method is not applicable in this. Okay. Because I gave you the reason. Towards the end, cos h does not approach 0, it approaches 1. Yeah. So thank you for correcting. Yeah. If you put x as 2 over here, 2 minus 2 is 0. And at the same time, we don't have this proper format also. A raised to x minus 1. Third thing, we cannot just simplify this. So let x is equal to 2 plus h. As x approaches 2, h will approach 0. Okay. So this will be limit h approaches 0. E raised to 2 plus h minus e raised to 2 upon 2 plus h minus 2. Now this is indices. H approaches 0. E raised to 2 into e raised to h. And down it is h. Because 2 and 2 gone, down it is h. Guys, is this correct? E raised to 2 into e raised to h.
Yes, sir.
Take e raised to 2 common. Guys, what about this?
Log E.
Log E.
Correct, that is log e.
Is
And
D
this
square.
e square is a constant. There is no h term in this. And log e is 1. Okay. So here this problem we had to do this h method. Either LHL or RHL, I relied on RHL for this problem.
So, but if you do LHL, you'll get the same answer, right?
Same answer, same answer. X approaches towards 1. Hey guys, let me not solve this problem, otherwise it will be a waste of my time, your time. It is the same problem like the previous one. Okay, same problem. Okay. So question number 20, sub question 2 is also done. It's the same problem. It is the same problem. Yeah. Question number 4. Limit x approaches 0. X approaches 1, sorry. E raised to minus x minus e raised to minus 1. X minus 1. Now people keep asking me if it is minus x, then should we use LHL? The answer is you can use anything. Okay, now first 1 minus 1 is 0. Format is not there of the formula. Let x is equal to 1 plus h. As x approaches 1, h will approach 0. limit h approaching 0 minus of 1 plus h minus e raised to minus 1 1 plus h minus 1 minus 1 minus h minus 1. Multiply this minus with both the terms. Indices. Take minus 1 common, e raised to minus 1 rather. Can we apply the formula here?
No, we need to multiply divide by minus.
This is minus h. So down also we require minus h. So multiply and divide with minus. That is minus 1. Okay, or you can just write minus, not a problem. Okay. So I'm writing minus over here and I'm putting minus within the bracket. I made it minus h because this is minus h. Now what about this part? What about this part?
Log E.
Correct. So e raised to minus 1 log e into minus. E raised to minus 1 log e into minus. This is minus 1. This is 1 upon e into minus 1. Answer is minus 1 upon e. As h approaches 0, minus h will also approach 0. So if you multiply minus on both the sides, it will still remain 0. Okay. H approaches 0. 2h will approach what? Randomly I'm asking this. H approaches 0, 2h approaches what?
0.
0, sir.
0. H by 2 approaches what?
0.
0, because 0 by 2 will be 0. 2 plus h will approach what?
2.
2.
2. So this won't be 0. So in this kind of situation, we cannot apply the formula. So whatever formula we have done, sin x upon x, tan x upon x, and this 3 formulae, it should be always 0. Okay. H approaches 0. Therefore, sin h will approach what?
0.
0, because sin 0 is 0. Cos h will approach what?
1.
1.
1, because cos 0 is 1. Okay. So here we cannot apply the formula. Tan h will approach what?
0.
0. Okay. This was just for your knowledge. Question number 5. X approaching 0. 3 raised to x minus 1 upon root of 1 plus x minus 1.
So rationalize the denominator.
Perfect. Rationalize the denominator, root minus some value. This we revised yesterday also. What is the final answer of this? I'm asking the final answer.
So 1 plus x minus 1.
So what is that?
X.
X.
Correct. Now what is this?
So log 3.
Log 3 into here. Put the value of x as 0. So this will be
2.
2 log 3. What is the base of this log?
E.
Correct. Question number 8, 10, and 11 of the worksheet is for self-study because I'm pretty sure that you people will be able to solve. 8, 10, and 11. I'll be solving question number 9 right now. Limit x approaching 0, a raised to x minus b raised to x upon sin x. X approaching 0. I require minus 1 over here. So if I'm putting minus 1 over here, after b raised to x, what will I write?
We add 1.
We add 1. Brackets. Now there is x over here and x over here also. So all these terms will have x beneath it. Okay. X common. I took this x common. We have to do that before cancellation and value substitution. So now cancel it. Value substitution. Sorry, formula application. Log a minus log b upon 1. So we cancelled out and then we applied the formula. Yesterday itself we discussed what is log a minus log b.
Log A upon B.
Log a upon b. Log a upon b. I'm taking you to question number 13. This we did in class also. This Monday itself. E raised to minus x. LCM. This is the denominator. So this is also the denominator. And this is already the denominator. So these two terms will remain with each other. They both are the denominators. Okay. Now this part.
So the numerator is in the form of e raised to x minus 1 the whole square.
Correct. So e raised to x the whole square. This part. I will write it as minus 2 e raised to x into 1. Putting a 1 over here does not really matter because e raised to x into 1 is e raised to x. And this part, this one, will be written as plus 1 square. Now we should practice this several times. So why we are writing in this format is because somebody rightly said this is a minus b the whole square. A minus b the whole square. So this is going to be e raised to x minus 1 the whole square. Now group the squares. This square and this square. So the terms I'm grouping upon e raised to x. That is 1 upon e raised to x. Apply the formula and value substitution. Put x as 0 over here. One. At home, you can practice this. Later on. Okay. Question number 15. Limit x approaching 0. There is a correction in the problem. It should be x approaching 0 in the worksheet. One plus cos, one minus cos. Applied half angle. Square and root is gone for sine. So it will be only sine, but then 2 will have a root. And we can split the roots because it is multiplication between 2 and sine square x by 2. Divide by x, multiply by x. There is x over here. Down. Root 2 x by 2 x by 2.
So the x can cancel. And
So
then
one
you
of the x will get cancelled, rightly said, correct. After cancellation, value substitution. Log e root 2, 1 and half. Now this 2 will go up 2 by root 2 because log e is 1 and 2 by root 2 is root 2. X approaches 0. X by 2 also approaches 0. Question 17, sub question 3. No, that is from a different type. Question number 16, sub question 3. 16.1 to 17.1 will not do for this exam. Okay, so just ignore those problems. 16.1 to 17.1. Yeah, 16 sub question 3. 16.3 and 17.3 not from this formula, sorry. Let's go to 18 sub question 1. Okay. Limit x approaches 0. E raised to ax minus 1 upon sin x. Relatively a very simple problem. Upon ax into ax. Upon x into x. Now see, this type of problems, x was not there. X was not there when it so we are multiplying and dividing with ax. So in some problems, x is there. So in that case, we'll just multiply and divide with a. I hope you're understanding the difference. X will get cancelled. Formula application. Log e into a upon 1. 1 into a, which is a. X approaches 0. So ax will also approach 0. Ax will also approach 0. Okay. Please try question number 18 sub question 2. I'll just wait for you.
Now, could you write the question on the screen?
You don't have the worksheet. Question number 18 sub question 2. X approaching 0. E raised to x minus 1 upon sin x square. Numerator. There is x square over here. Multiply and divide with x square. Denominator. Multiply and divide with x square. This and this is 1. This is getting cancelled. Okay, so down it is 1 and up it is, sorry, it is not 1, it is log e. As per the formula. A raised to x minus 1 upon x, which is log a. So this is 1. X approaches 0, therefore x square will also approach 0. Question number 20, sub question 1 is for self-study. Because it is rationalization problem. We have already done such kind of problem. 21, sub question 1. Limit x approaching towards 0. Do you need any explanation for these steps? Do you need any explanation for these steps, guys?
No, sir.
Okay. Now this is 3x. So down 3x, multiply with 3x. This is x. Divide and multiply with x. This is 3x and divide and multiply with 3x. But then don't be in a hurry to complete the problem. It has to be systematic. Minus 3 raised to x minus 1 upon x. This is log 2. Okay, sorry, no application of formula because this x is remaining. We'll have to cancel out this x. Otherwise, if this x is 0, it will be undefined. For that reason, I'll take this x common. 2 raised to 3x minus 1 upon 3x minus 3 raised to x minus 1 upon x. So this x and this x is getting cancelled. Okay.
So
Now formula application. Yeah, tell
you
me.
missed the 3 because it's 3x on the top.
Yeah. Correct. Thank you. Parallelly on my WhatsApp also replying to SYC kids. Now it is correct.
Yes. Sir.
This 3 should be there. Absolutely correct. Good. Now this part, and this part, formula will be applied. Okay. And formula will be applied because x approaching 0, so 3x also approaches 0. Don't ask me again and again. Yesterday also many were asking, should we write this? Once I have given instruction, please do not ask me this again. So 3 log 2 minus log 3 upon. This is supposed to be 1. Okay.
So
Now
there's
log.
3 also in the denominator.
Yeah. Sorry. There is 3 also. Okay, this 3. So correct. You should not miss out on such kind of information. Good. Log a raised to b is b log a. This formula, this property of log I have already given to you. So b log a can also be written as log a raised to b. So b log a, log a raised to b. Guys, what is log a minus log b?
Log A upon B.
Log a upon.
So in the notes, there's a different answer.
1 second. Yeah, that's fine. That's fine. So after this step, now they are simplifying it. Sorry, splitting it. 3 log 2 upon 3 minus log 3 upon 3. And that is their answer. 3 they will cancel in the first term.
Okay.
But then it's okay, you can do this. Question
So
number
log
18,
so
question 3.
log 2 minus log 3 by 3 is right? The answer.
Yeah, and that is a worksheet answer also. No?
Okay, sir.
Log 3 by 3 meaning is what? 1 by 3 into log 3.
Okay.
Okay, so you can do this, you can do that, not a problem at all. 18, sub question 3. Limit x approaching 0, 3 raised to 2x minus 1, 2 raised to 3x minus 1. Limit x approaching 0, 9 raised to x minus 1. This was asked in the test. 3 square is 9, 2 cube is 8. It was a very simple 4-mark problem. Upon x into x upon x into x. This x and this x is getting cancelled. What will be the answer?
Log 9 upon log 8.
Log 9 upon log 8. You cannot cancel log and log. Okay. And base of both the log is e. Euler's constant, natural log. Question number 22, sub question 2.
Sir, I have a question.
Ask.
In that sum, are you allowed to multiply and divide by 2x in the numerator and 3x in the denominator?
Yes.
So then you get log 3 upon log 2 and
Okay. So
multiply 2 by 3.
acha. Log 3 upon log 2 into
2 by 3.
2 by 3, right?
Yes, sir.
This is who?
Rehan.
Yes, Ryan, good. You can take this over here. You can take this over here.
Yes.
Log 3
Haan.
square, log 2 cube, log 9 upon log 8.
Yes, sir. Okay, sir.
Answers are matching.
So can
But
you
then
leave
good.
it as 2 log 3?
Yeah, this also you can leave it at this.
So there's
Multiple
no
ways.
formula called log A upon log B, right?
No, there is nothing called as log A upon log B. But then if it is log A upon B, we can just write log A minus log B.
Yes, sir.
Okay. (22) sub question 2. Limit x approaching 0, (3 raised to 2 plus x minus 9 upon sin x. Okay. So x approaching 0, nine is 3 square, and here I have applied indices. Anything common in the numerator?
3 raised to 2.
3 raised to 2. So I'll take 3 raised to 2 common. So this is 9. Nine log 3 upon 1. 9 log 3 upon 1. Did you understand this?
Yes, sir.
Yes, sir.
So then does it become log 3 raised to 9?
3 raised to 9 will be a very big value. So leave it as it is.
Yeah. Oh, okay.
If it is smaller values, then yeah. One extra problem. This 21 raised to x, I'll just write it as 7 raised to x into 3 raised to x. This is not in the worksheet. I forgot to include this category. So by indices, I'm just writing this. What is the common term between the first two terms?
7 raised to x.
Clear? And the next two terms, minus 1 is common. So 7 raised to x minus 1, 3 raised to x minus 1 upon x. Let's make it x square, sorry. Make it x square.
So why x square? You can just separate the denominators
No,
by.
I forgot to include x square in the question.
Okay, sir.
So 7 raised to x minus 1, 3 raised to x minus 1 upon x square. So that x square,
So how did you get minus 1 in 7 raised to x?
I'll show you the previous slide.
Okay, understood, sir.
Okay. Distribute x. This is not splitting. This is distribution because there is multiplication over here.
So where did the minus sign go between both the terms in the numerator?
7 raised to x common. 7
Yeah.
raised to x.
Oh,
Minus 1 common. 3 raised
yeah,
to x minus 1.
yeah. Okay.
So 7 raised to x minus 1 into 3 raised to x minus 1. You can practice this at home. 15 raised to x minus 5 raised to x minus 3 raised to x plus 1 upon x square. Okay. So guys, with this, basically, we have completed the first session. And this is based on the first formula, this formula. Okay. I'm just taking a 15 minutes break